Fibonacci series with integral calculus. Fibonacci series with integral calculus. This is the discussion that we have started. Fibonacci series with integral calculus. Fibonacci series can be computed through integral calculus. What is the Fibonacci series? We have given a very interesting topic on it, that is amoeba division. Amoeba is dividing into two, or any unicellular organism that is dividing into two. If I get a unicellular organism that is newly born, then today it is born, then day after tomorrow it will start dividing into two on daily basis. Okay, so today it is one, tomorrow it is one, and day after tomorrow it is two. Day after tomorrow, day after tomorrow is 2, and then next day it is 3, and what is newly born on day after tomorrow, it will become 2 after one more day. I will please watch our previous session on this, and then it will be like, if I take a amoeba which can divide into 2, and when it is newly born, then if it is born today, then tomorrow it will wait, and day after tomorrow it will become 2, then daily basis it will become 222, and whoever is born, it will on that day, and next day it will wait, and then next day, third day onwards, it will start becoming 2 again on daily basis. If someone start counting the number of amoeba on daily basis, then it will become a Fibonacci series. If day number 1, then 1, day number 2, then 1, day number 3, then 2, day number 4, then 3, because there are two members, and one member will again divide into one more. So 3, day number 5, then two members are ready to multiply. So 3 plus 2, 5. Day number 5 is 5. Day number 6, three members are ready to multiply. Then 5 plus 3, 8, and so on. Okay, means people are who are watching it, they are saying it looks like that on a particular day, the number of amoeba are same as addition of last 2 days. In general, if people are saying addition of last 2 days, if I leave the first day and second day, then third day it is addition of last 2 days. Though it is nothing to do with the amoeba division. But looking at the series fundamental, it looks like in that manner. The third day is summation of first 2 days. Fourth day is summation of last 2 days. Fifth day is summation of last 2 days. Third day and fourth day, and so on. So someone can say, if I generally I describe, if I come into calculus, if I come into calculus, then there are independent component and there are dependent component. If I come to calculus, then this is dependent component of this is independent component, and this is dependent component. This is x-axis. This is function over x-axis or y-axis. If this is x-axis, then this is function over x or y-axis. X-axis is number of days. Day number 0, day number 1, day number 2, day number 3, day number 4, day number 5. Against each day, what is the number of amoeba? So day number 1, amoeba count is 1. Day number 2, amoeba count is 1. Day number 3, amoeba count is 2. Day number 4, amoeba count is 3. Day number 5, amoeba count is 5. And so on. If that is the scenario, then the date number, we can say it is x-axis, and amoeba count on that particular day is y-axis. We can say function over x. So function over x equal to function over x minus 1 plus function over x minus 2. At x, what is the number of amoeba is same as at x minus 1 plus x minus 2, what the amoeba is. We have to add it. Okay, this has nothing to do with amoeba multiplication, because amoeba, once it is born, that day or next day it will not multiply. Next third day onward, it will start multiplying into 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, infinite, something like that. Okay, in that manner, the number of amoeba what we are counting is Fibonacci series. But when people saw the series, It looks like that any day is addition of previous 2 days. This is called Fibonacci series. Okay. Another people came, we will talk about that also. But this, if I say that particular day is addition of fx equal to fx minus 1 plus fx minus 2, then it is not algebra. Algebra means I want fx in terms of x only, not x minus 1 or x minus 2. Okay, someone worked toward it and he found that fx equal to phi to the power x minus phi, phi to the phi 1 to the power x minus phi 2 to the power x divided by square root of phi. Okay, where phi 1 and phi 2 are constant. If I have a constant, these are, I believe these are called magic numbers also. If I have magic number as phi 1 and phi 2, then phi 1 to the power x minus phi 2 to the power x divided by square root of 5 is actually fx, function over x or number of amoeba on day number x. What is phi 1? Phi 1 is a square root of 5 plus 1 by 2. Phi 2 is phi 2, I'm sorry. Phi 1 is 1 plus the square root of 5 by 2. It looks same, but it matters. Phi 2 is 1 minus the square root of 5 by 2. 1 is 1 plus the square root of 5 by 2. 1 is 1 minus the square root of 5 by 2. Phi 1, phi 2. Phi to the power x minus phi 1 to the power x minus phi to the power x by a square root of 5. This is the value, this is the amoeba count on day number x. Make sense? Okay, now if I solve it, then 1 plus the square root of 5 by 2 whole to the power x is phi 1 to the power x minus 1 minus the square root of 5 by 2 to the power x is phi 2 to the power x. Phi 2 is negative. 1 minus the square root of 5 by 2 is negative. Means it will show different value for different x. If x is odd number, then full value will be negative. If x is even number, then full number will be positive. Anyway, phi 1 to the power x minus phi to the power x minus is there. This proves that when x is odd number, then full will be positive. Means phi 1 to the power x plus phi to the power phi 2 to the power x, where phi 2 is positive number. We reversed it, square root of 5 minus 1 by 2. Phi 2 is 1 minus the square root of 5 by 2. I reversed it and said it is a square root of 5 minus 1 by 2. Phi 1 to the power x minus phi 2 to the power x, where phi 2 is 1 minus a square root of 5 by 2. If I reverse it, it becomes a square root of 5 minus 1 by 2 into minus 1 to the power x. Minus I took it out. Means when x is odd number, that is negative, and outside negative it is positive. I renamed it and I said phi 1 is a and phi 2 and minus phi 2 is b. I mean fx equal to a to the power x minus b to the power x by square root of 5 if x is even number. A to the power x plus b to the power x by a square root of 5 if x is odd number, where a is same as phi 1, that is square root of 5 plus 1 by 2, where b is minus 5, means the square root of 5 minus 1 by 2. Okay, if that is the scenario, then we can rephrase it function over x in Fibonacci series. On the xth day, what is the number of amoeba I can see? Xth day, x is even or odd. If x is odd, then fx equal to a to the power x plus b to the power x by 2. If x is even number, then fx equal to a to the power x minus b to the power x by 2, x by square root of 5, square root of 5, both places. One is plus, one is minus. This will help us to go with the calculus. Okay, what is sigma sign? If I talk about sigma sign in algebra, that sign gives the notation of addition. I believe addition. And tilted u, inverted u, give the notation, hope I think for multiplication. This is what I remember. Okay, sigma sign is for addition and this sign is for multiplication. Whereas this sign, people know very well, snake sign or whatever, the integral sign is for addition again, but addition of area. Okay, if the sigma sign is for addition of anything. If I'm adding some number, then it is sigma sign. Multiplying some number, then it is inverted u. This is what I doubt about it, but this is how I think so. An integral sign is for summation of area, particularly area, nothing else other than this. If I have so many area to be added and all area are contiguous to each other, then that is nothing but integral calculus. What do you mean? I say consider this is a width on x-axis, and I have a graph. If this is width of if this is x-axis and I have x-axis, I have a width here on x-axis. This width goes up and it hits a curve. Consider there is a curve called gx. Consider there is a curve called gx. I have divided x-axis into many parts. This part, but all are contiguous, though they are non-overlapping, but they are contiguous. This part, then this part, then this part, then this part, and so on. For each part, I have an area with gx, next area with gx, next area with gx, next area with gx. I have contiguous area, sub-area section. If I want to add all the sub area, this is area number 1, area number 2, area number 3. Consider this is x1, x2, x3, x4, x5. Then and this is gx. I can write first area as limit x equal to x1 to x2 gx dx. Second area is x2 to x3 gx dx. Like so I can write more or less. And last area, consider the last area is n to n plus 1 gx dx. If I have area summation, then I can denote it as limit x equal to 1 to n plus 1 gx dx. Okay, so limit sign is repeated addition of area. Sigma sign is repeated addition of fx. Sigma fx. Fx can be area, volume, number, whatsoever, doesn't matter. It is simple summation. Whereas limit sign for integral calculus, it is area calculation of limit x1 to x2 gx dx. If I draw a graph gx and if I intersect it with at x1 and x2, whatever the area is, that area is what it is. So if I say x1 1 to n plus 1, then on x-axis 1 to n plus 1, whatever the area is, it will give the area. That is nothing but summation of 1 to 2, 2 to 3, 3 to 4, and n to n plus 1 sub area. I can write in sigma also. Sigma x equal to 1 to n plus 1 to n plus 1 gx dx integration something like that. Gx dx integration actually calculate the area from where. So if I say I x equal to 1 to x equal to n plus 1, then if I say summation and then it is x1 to x2 or something like that, then it will break and it will calculate the repeated summation. This is not a perfect representation in sigma. Perfect representation is integral calculus representation only. That is limit x equal to 1 to n plus 1 gx dx. That is same as limit x equal to 1 to 2 gx dx plus 2 to 3 gx dx plus x equal to 3 to 4 gx dx plus x equal to n minus n to n plus 1 n to n plus 1 gx dx. So there are different notations, different meaning. Anyway, now we are in a phase to calculate the addition of Fibonacci series, where the x is even number. What do you mean? X is 1, then it is x is 1, x is 2, x is 3, x is 4, x is 5, and then x is n, where n is even number. Consider in that manner. If that is the case, then what is summation of all the Fibonacci series number when x is even number? Means summation x equal to 2, that is the first even number, because x equal to 0 is 0 only. So summation x equal to 2 to x equal to n fx. Okay, means fx plus fx plus fx plus fx plus fx plus so on, where x is 2, x is 4, x is 6, x is 8, x is 10, and so on. So fx at 2 is 1, fx at 4 is 3, this is what I remember. Fx at 6 is 8. Okay, so slot number 2 is 1, slot number 1 is 1, 1, 1, 2, 3, 5, 8, okay, uh, 13 and so on. So when x is 1, the fx, that is Fibonacci number is 1, 1, x is 2, then it is 1, x is 4, then it is 3, x is 6, then it is 8, x is 8 and so on. What is the Fibonacci number addition when x equal to 2, x equal to 4 and so on? What I want is summation sigma x equal to 2 to n where n is even number fx. What would be the Fibonacci number? Now the simple solution to this problem is u2 or fx2. If consider for simplicity, I write function over x at x equal to 2 is u2, or I can go like this only fx2 function and at x equal to 2 equal to function at x equal to 3 minus function at x equal to 1. Makes sense? If I settle it down, function at x equal to 3, Fibonacci series at x equal to 3 equal to Fibonacci series at x equal to 1 plus Fibonacci series at x equal to 2. Fibonacci series at x equal to 3 equal to Fibonacci series at x equal to 2 plus x equal to 1. Fibonacci series at x equal to 2 equal to Fibonacci series at x equal to 3 minus x equal to 1. Makes sense? I can rewrite it. Left hand side fx2 equal to fx3 minus fx1. fx4 equal to fx5 minus fx3. Makes sense? fx6 equal to fx7 minus fx6 fx5 means diagonally they are cutting each other. Fx3 equal to fx2 equal to fx3 minus fx1, fx4 equal to fx5 minus fx3, fx6 equal to fx7 minus fx5, fx fxn 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 equal to fxn plus 1 minus fxn minus 1. If I add both sides, it will become fx2 plus fx4 plus fx6 plus fx at x equal to n. That will be equal to now f3 minus f1 plus f5 minus f3 plus f7 minus f5. Okay, all are cutting each other. At the end, it will be f. It will be up. It will be fn minus 1 minus fn minus 2, fn plus 1 minus fn minus 1 means all will cut each other, and the first term minus fx1 and last term fx at n plus 1 will remain. More or less, summation of all the even slots in Fibonacci series is equal to fxn plus 1 minus fx1. Fx n plus fx at n plus 1 minus fx at n equal to 1, that is 1 only. Means summation of Fibonacci series at fx equal to 2 plus fx equal to 4 plus fx equal to 6 plus fx equal to 8 and so on up to fx equal to n, where n is even number, that equal to fx n plus 1, that is the odd number. N plus 1 is odd number. Fibonacci series at n plus 1 minus Fibonacci series at x equal to 1, that is 1. Okay, can I prove it through integral calculus? That is what we are thinking. If someone is watching our previous session, then we calculated, okay, anyway, we'll try again. What is Fibonacci series for even slot? That is a to the power x minus b to the power x by the square root of 5. This is fx. A to the a, where a is the square root of 5 plus 1 by 2, b is the square root of 5 minus 1 by 2, a to the power x plus, a to the power x minus b to the power x by square root of 5. Okay, if I try to kind of this, anyway, this is the, if I try to calculate the summation of all even number means I have x equal to 2, x equal to 4, x equal to 6, x equal to 8 and so on, x equal to n. where n is even number. If I try to add, when x equal to 1, sorry, x equal to 2, we have 1. When x equal to 4, we have 3. This is what I think so. X equal to 6, then I have 8, and so on. So if I take fx, if I connect all the top points, it will generate a function called fx. And fx is a discrete function which is defined only at x equal to 2, 4, 6, 8, and so on. So if I talk about fx, then fx equal to a to the power x minus b to the power x by square root of 5. This is what someone had deduced. Where x equal to square root of 5 plus 1 by 2 and b equal to b equal to square root of 5 minus 1 by 2. Okay, can I have another function called gx as a continuous function, and we have x equal to 2, x equal to 4. In between, if I take area, it will hit gx, and this area will be exactly same as left hand side what is fx. Means fx at x equal to 1 equal to limit x equal to 1 to I'm sorry, fx at x equal to 2, because we are taking even number. Fx at x equal to 2 is equal to limit x equal to 2 to 4 gx dx. What is gx that I have to find? Means if I take any arbitrary x, then fx, then the fx is a to the power x plus, so a to the power x minus b to the power x by square root of 5. That will be same as limit x to x plus 2 gx dx. If this is x equal to x, that is x is even number, x to x plus 2, this is the area strip, and that will go and hit gx. It will go and hit gx. This area strip will be exactly same as left hand side fx equal to x. At x equal to x, what is fx? Means for each fx vertical, I have right hand side area that is matching to it. Fx at x equal to x equal to limit x equal to x plus 2 gx dx. Okay, then I have to find gx in that manner. Fx at x equal to x is a to the power x minus b to the power x. What gx value I take, that then gx dx from x to x plus 2 will be exactly same as a to the power x minus b to the power x. We have seen it. Please watch our previous video. That is called successive approximation. I can start gx. If I take gx as a to the power x minus b to the power x, then integration will be a to the power x by logarithmic of a plus minus b to the power x by logarithmic of b. If I settle down the limit x to x plus 2, it will be x x to the power, sorry, a to the power x plus 2 minus a square by logarithmic of a minus a to the power b to the power x plus 2 minus b to the power x by logarithmic of b. Whereas we want a to the power x minus b to the power x. If I want in that manner, we will start gx as logarithmic of a divided by a square minus divided by a square minus 1 a to the power x minus logarithmic of b by b square minus 1 into a to the b to the power x, so that after doing the integration they will cut each other, and finally a to the power x minus b to the power x will remain. If someone try integrating log a by a square minus 1 into a to the power x minus log b by log b by b square minus 1 into b to the power x, if someone is trying in this manner, integrating and then setting x to x plus 2, he will get a to the power x minus b to the power x, because a to the power x integration is a to the power x by log of a. Log of a, they will cut each other. A to the power x limit x to x plus 2 will be a to the power x plus 2 minus a to the power x. A to the power x I can take outside, a square minus 1. Denominator is a square minus 1. They will cut each other. At the end, it will become a to the power x minus b to the power x. Means if I take a function gx as logarithmic of a by a square minus 1 into a to the power x minus b log b by b square minus 1 into a to the power a to the power bx, integrating with dx and then setting limit x to x plus 2, will become a to the power x minus b to the power x. Means at any x equal to x, I have fx, and that is same as x to x plus 2 integration gx dx. Means all the fx will be can be replaced by area on right hand side. means summation of fx, summation x equal to 2 to n fx will be same as integrating all the sub area, adding all the sub area, which starts from 2 and it goes till n plus 2, that is the last sub area. Means if I integrate 2x equal to 2 to n plus 2, 2 to n plus 2 gx dx, I'll get the full sub area, that is nothing but the full addition, what we are trying, where n is even number. So we will try, so what will happen? So gx is log a by a square minus 1, a to the power x minus log b by b square minus 1, b to the power x. Okay, if I try integrating it with dx, it will become like a to the power x by a square minus 1 minus b to the power x by b square minus 1. Now set the limit 2 to n plus 2. That will be a to the power n plus 2 minus a square by a square minus 1 minus b to the power n plus 2 minus b square by b square minus 1. Makes sense? Okay, now let's take out a from numerator. Then it will be a, and in bracket a to the power n plus 1 minus a by a square minus 1 minus b in bracket b to the power n plus 1 minus b. Denominator is b square minus 1. Let's settle down a square minus 1. We have already done it. A is 1 plus a square root of 5 by 2. A square will be 1 plus 5, 6. 6 plus 2 a square root of 5. 1 plus a square root of 5 by 2 whole square will be 6 plus 2 a square root of 5 by 4. Okay, this is what it will be, I think so. Okay, so minus 1, a square minus 1. So it will become 6 minus 4. 2 plus 2 a square root of 5 by 4. 2 I can take out, it will become 1 plus a square root of 5 by 2. It is become a only. A square minus 1 is a only. Similarly, if tries b square minus 1, b is square root of 5 minus 1 by 2 minus 1. That will be 6 minus 2 a square root of 5 by 4 minus 1. 3, that will become that will become 2 minus 2 a square root of 5 by 4. 1 minus 1 minus a square root of 5 by 2, that is minus b. So b square minus 1 is minus b, a square minus 1 is a. Now numerator we have a to the power n plus 2 minus a square by a. Anyway, it will become a to the power n plus 1 minus a. Minus and bottom is denominator is minus b, minus minus plus. B will cut. Now numerator is b to the power n plus 2 minus b square. B to the power n plus 1 minus b. Whole become a to the power n plus 1 minus a, b to the power n plus 1 minus b. A to the power n plus 1 plus b to the power n plus 1 minus a plus b. If I say a plus b, then it is a to the power 1 plus b to the power 1. That is nothing but Fibonacci series number at x equal to 1, which is an odd number. So it will be a to the power 1 plus b to the power 1. Now we have a to the power n plus 1 plus b to the power n plus 1. If n is even number, then n plus 1 is odd number. If it is odd number, then Fibonacci series fx at x equal to n plus 1 will be a to the power n plus 1 plus b to the power n plus 1. If n plus 1 is even number, then Fibonacci series at n plus 1 will be a to the power n plus 1 minus b to the power n plus 1. But since it is odd number, it is a to the power n plus 1 plus b to the power n plus 1 minus Fibonacci series at x equal to 1. That is, anyway, a plus b will be 1 only. Anyone can try. 1 square root of 5 plus 1 by 2 plus square root of 5 minus 1 by 2. Okay, then it will be 2 square root of 5 by 2, a square root of 5. Anyway, let's do let. Okay, this is how it is. Now if people remember, a kind of the Fibonacci series is actually the fx Fibonacci series is phi to the power x, phi 1 to the power x minus phi 2 to the power x divided by square root of 5. A square root of 5 deliberately I have not taken into consideration for simplicity. So we can say that addition of the full all the even slots Fibonacci series is a to the power n plus 1 plus b to the power n plus 1 minus and in bracket a plus b whole divided by square root of 5. Okay, means a plus b by a square root of 5 will become 1 only. Okay, so it will become a to the power n plus 1 plus b to the power n plus 1 by square root of 5 minus 1, or minus function Fibonacci series at x equal to 1. Fibonacci series at x equal to n plus 1 minus Fibonacci series at x equal to 1. This is exactly what we had got in the normal summation. fx2 equal to fx3 minus 1, fx4 equal to fx5 minus fx3. Like that, fxn equal to fxn plus 1 minus fxn minus 1. If I add so, then summation of all the even number Fibonacci series is fxn plus 1 minus fxx1. This is exactly same what we are getting through integral calculus also. This is what we can validate but here here the answer is in numerous. If I calculate through integral calculus, and I have in term of a and b, where a square minus 1 is 1, b square, sorry, a square minus 1 is a, b square minus 1 is minus b. Okay, if I do in that manner, then we can compute many more things, and many more things we will see indeed. This is Fibonacci series with integral calculus. Can we do computation over Fibonacci? Anything, not Fibonacci series. In numerous series, all the computation we can do through integral calculus. No need to remember that I have to. We will do third thing also. Summation of full Fibonacci series up to n is fx at n plus 1, fx at n plus 2 minus fx at 2. That also we will do, but methodology will be different. Here we are doing fx2 equal to fx3 minus 1, fx4 equal to fx5 minus fx4, like so. If I calculate all, then how many ways someone will remember? Not possible. So integral calculus is the unique way to calculate all the computation. Only thing is integral calculus talk about summation of area, not summation of vertex. Someone has to change the vertical concept into area concept. That change is required. And then someone can proceed in integral calculus. Obviously, these are not available in any of the book. Anyone can try. Please don't mind supporting us or mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 India country code 9483160610 is the telephone number.